Math Conquerors, and welcome to Lesson 9-3, Transformations of Quadratic Functions. Before we begin this lesson today, we need to go over a few definitions, and if you'd like, you could write these down in your math notebook. We need to talk about a parent graph. A parent graph is f of x equals x squared. There's nothing added. It only has an a, it does not have a b, and it does not have a c. Remember, our standard form is ax squared plus bx plus c. Today we are going to be making some transformations. And transformation just means to change the position. There are four types of transformations we're going to be doing today. The first one is translation. A translation will move our parabolas up, down, right, or left. Number two, a dilation makes the graph narrower or wider. And we'll be using stretched for the word narrower and compressed for the word wider. The third transformation is called reflection. And with a reflection, the figure or the parabola is a mirror image across a line. And in these lessons, it's either going to be across the x-axis or the y-axis. If you will look on page 17 in your Chapter 9 Master Resources, I'm going to be working some of the problems on that page. And the first type of transformation we're going to look at is called translation. Translation explains to us how the parabola moves. With a translation, the parabola can move up, down, left, or right. How the parabola moves depends on the c value. Now notice here we have put in a c value, and our c value is 1. Now, over on the graph, I have drawn a parabola that is on the 0 point on the x-axis. The c value moves the parabola up or down. Now, our rule is if c is greater than 0, we're going to move up. If c is less than 0, we're going to move down. So this function, the parent function, x squared plus 1, c is 1, so we're going to move the parabola up 1 unit. And this is number 1 on page 17. So your answer would be that we moved the parent function up 1 unit. Okay, now on page 17, this is number 4, and our problem is f of x equals 20 plus x squared. Now, I rewrote the problem so that I could see it in our normal standard ax squared plus bx plus c form, and it says x squared plus 20. So c is 20, and it's positive, so I'm going to start with my parent graph, and then I'm going to move up 20. Now I counted by 5s, and I moved it up 20. So my answer would be up 20 units. Number 6 is written negative 1/2 plus x squared. Now I wanted to write it where I could see it better. F of x equals x squared minus 1/2. So now this is not positive anymore, it's negative. So instead of moving up, I'm going to be moving down. So my parent graph is on the 0, and then here's 1, and I moved it down 1/2. So it's just going to be moving up or down, and in a minute we're going to look at can move left or right. Now on page 17, on number 7, it says g of x equals x squared plus 8/9. Again, c is positive, so my answer would be that the parabola is going to move up 8/9 unit. Number 8, f of x equals x squared minus 3/10. So it's negative. The c is negative. So I'm going to move down 3/10 of a unit. Okay, now on page 17, we're going to be looking at some different types of problems. So far, our translations have been shifting our parabola in a vertical shift. When the parent function is written as x minus something squared, it's going to change to a horizontal shift. That means I'm going to move to the left or to the right. Now let's look at this and let's remember that we can set this equal to 0. I can do 2, but I don't need to. I don't need to say x minus 6 equals 0, x minus 6 equals 0. I know I have 2 of them, but I'm going to get a 6. Now we have to be careful because when we first look at it, we may think that it's going to shift to the left, but if you set it equal to 0, it's going to give you a positive 6, which is going to shift you 6 units to the right. So when they are written squared, it's going to be a horizontal shift instead of a vertical shift. Alright, let's look at this one. G of x equals x plus 1. If you set x plus 1 equals to 0, it gives you a negative 1, and you're going to shift 1 unit to the left. So this is our second type of translation. The first one was vertical, this one is horizontal. Okay, on page 17 for number 5, our function is a negative 2 plus x squared. I did not like how that looked, so I rewrote it in regular form, x minus 2 squared. And remember, this is x minus 2 equals 0, x equals 2. So we're going to do 2 units to the right. It's almost like thinking, okay, I'm going to do the opposite of this. Instead of negative, you'd go to the left. You're setting it equal to the 0 and solving, so that puts you in the opposite direction right. Number 9, g of x equals x plus 4 squared. Remember, x plus 4 equals 0. That will give me a negative 4, and it's going to move my parabola 4 units to the left. Okay, now if you'll turn to page 18 in your chapter 9 master resources, you'll see the second type of transformation that we're going to talk about, and it is called dilation. Dilation either makes our parabola more narrow or more wider. If you think about a rubber band, if you stretch it, it becomes narrower, and if you let it go or compress it, it becomes wider. So on page 18, you'll see there's a rule. And the rule in the short version is if A is greater than 1, then we're going to stretch. And if A is less than 1, we're going to compress. Now remember, our standard form is ax squared plus bx plus c equals 0. So we're going to start out with that parent function x squared. And we want to know what happens to our parabola if we plug in a 2 in here, and now we have an a that is a 2. Well, our rule says that if 2 is greater than 1, or a is greater than 1, then we're going to stretch. And so our answer would be stretch. So what's going to happen is it's the same parabola, but it becomes narrower. So if we drew this, would be the same parabola here. Whoops. Same parabola, but it would become a more narrower parabola. That's all that means. If I put that 2 in front of there, it's going to become more narrow. The last type of reflection we're going to talk about, the last type of transformation we're going to talk about is reflection, which is a mirror image. And the rule on page 18 says, if the function is negative, it reflects across the x-axis. That is what most of our problems in these worksheets are going to do. But if x is negative, it reflects across the y-axis. So let's look at this. B, the example B, says negative 1/2 x squared minus 3. Now we have many things to look at. The first thing we're going to look at is that we know it's a half. So A is less than 1, and if a half is less than 1, then it's compressed. That's the number 2, the dilation that we talked about. We also know that C is a negative 3, so we know that it's going to have to move down 3 units. Okay, that's the translation that we talked about. Our new thing that we're going to talk about is this negative sign right here. This negative sign makes our function negative. So it's going to be a mirrored image across the x-axis. And we know that negative turns our parabolas upside down. So I moved it down 3, 1, 2, 3, because that's what C told me to do. I'm leaving it compressed. Compressed means wider because the half is less than 1. And now I'm flipping it upside down because it's a mirror image. So now let's look at number 2 on page 18. And let's go walk through what we have learned and apply it. So it says g of x equals a negative x plus 1 squared. Now, this is not going to make a vertical shift. It's going to make a horizontal shift. And we see here that it's a plus 1. And if you set that equal to 0, it's actually going to be a negative 1. So we're going to go negative 1 units left. And we're also going to flip across the x-axis. Alright? Instead of the word flip, let's use reflect. It reflects over x-axis. Okay? Now on this one it says g of x equals a negative 1/4 x squared minus 1. Now we're actually going to have all 3 of our transformations occurring. So first let's look at this one. This is our c, and remember that's going to move it up. I'm sorry, not up, it's negative. Down 1 unit. The 1/4 is less than 1, so it's going to be compressed, or it's going to get wider, and the negative is going to reflect it over the x-axis.